Section 6.5, Graphing Linear Inequalities with Two Variables. By the end of today's lesson, you will be able to graph a linear inequality on a coordinate plane. Let's start by talking about what a solution to an inequality is. An ordered pair is a solution to an inequality if the inequality is true when x and y are plugged in. Let's look at what that means. In our first example, we're going to look at the inequality 3x minus y is less than or equal to 10. And we're going to test the first ordered pair, which is 0, 0, to see if that is a solution to our inequality. Remember, with ordered pairs, our first value is always our x-coordinate, and our second value is always our y-coordinate. So let's go ahead and plug in our values. 3 times x, which is 0, minus y, which is 0, is less than or equal to 10. Now we're going to simplify this. 3 times 0 is 0, minus 0 is less than or equal to 10. 0 minus 0 is 0, which is less than or equal to 10. So the question is that a true statement? Is 0 less than or equal to 10? Yes. And because it's a true statement, 0, 0 is a solution to our inequality. Let's check if the next ordered pair is also a solution. 5, 1. 5 being our x-coordinate and 1 being our y-coordinate. So let's look at the same inequality. 3 times x, in this case 5, minus y, which is 1, is less than or equal to 10. 3 times 5 is 15, minus 1, less than or equal to 10. 15 minus 1 is 14. So, is 14 less than or equal to 10? No, it's not. And since it is not a true statement, this ordered pair is not a solution to our inequality. Let's look at the third example, 4, 2. 4 is our x-coordinate and 2 is our y-coordinate. So let's go ahead and plug them into our inequality. 3 times x, which is 4, minus y, which is 2, needs to be less than or equal to 10. 3 times 4 is 12, minus 2, which is less than or equal to 10. 12 minus 2 is 10, less than or equal to 10. Is 10 less than or equal to 10? It is. So we can say that yes, 4, 2 is a solution to this inequality. Alright, the graph of a linear inequality with two variables is the graph of all solutions to the inequality. To the right is a graph of our previous example, 3x minus y, which is less than or equal to 10. The shaded area on this graph, right here, represents all of the possible solutions for this inequality. So check to see if the solutions we tested are in the shaded region. The first ordered pair we checked was 0, 0, which is right here. And we said yes, that is a solution. And it is. It falls in the shaded region. The next solution we checked was 5, 1. 5, 1 is here. Notice that ordered pair is not in the shaded region, and that is why it is not a solution. And the last ordered pair we tested was 4, 2. 4, 2. Notice that that ordered pair is on our line. And because our line is solid, it is a solution. Let's go ahead and look at graphing these inequalities. Steps to graphing a linear inequality. Step 1. You're going to start by graphing the boundary line. The boundary line is the straight line formed by the graph or the inequality when it's written in slope-intercept form. You are going to use a dotted line. So dotted lines can look like this. And you're going to use that kind of a line when you have a symbol less than or greater than. If you have the symbol less than or equal to, or the symbol greater than or equal to, you are going to draw a solid line. So solid line having no breaks in it. Step 2. The line is going to separate your coordinate plane into two halves, or two regions. You shade above or right for the symbols greater than or equal to, and you shade below or left for the symbols less than or equal to. Let's take a look at this first example. The inequality is x is less than 2. If we think of this as an equation, x equals 2, we know that equations written in this format are vertical lines. So we know that this inequality is going to produce a vertical line. So vertical line. We also know that it's going to be a dotted or dashed line because of the symbol that is used. So vertical line, and it's going to be a dotted line. So on the x-axis, we're going to plot 2, and we're going to draw a dotted vertical line going through 2. Now, because we want to represent all possible solutions, we need to do some shading. Here it says that we are going to shade above or right for greater than and equal to symbols, and we are going to shade below or left for less than symbols and less than or equal to symbol. In this problem, this is a less than symbol, so I need to shade below or to the left. So we are going to shade everything over here. And what that means is that any ordered pair in that shaded area is a solution to the inequality x is less than 2. All right, let's take a look at the second example. In our second example, negative x is greater than negative 1. Notice that x is not positive. Before we can get started, we have to rewrite this so that x is positive. So if the inequality is negative x is greater than negative 1, to make our inequality positive, we need to divide both sides by negative 1. Now remember, when you divide by a negative, you have to flip your inequality symbol. And negative 1 divided by negative 1 is positive 1. So the inequality we are actually graphing is x is less than 1. This is very similar to the problem number 1. This is also going to be a vertical line, and it is also going to be dotted. So it's a vertical dotted line going through 1. So on the x-axis, we're going to plot 1, and we're going to draw a vertical dotted line, or dashed. Now, we want to shade all values that are less than 1, less than our values to the left. So we're going to shade everything over here to the left. So again, any ordered pair that falls in that region would be a solution to our inequality. Example number 3. Y is greater than or equal to negative 2. This is an example of a horizontal line. So let's just write that because these are our notes. So horizontal line. And because it has the or equal to symbol, it's going to be a solid line. So on our y-axis, we're going to go to negative 2. And we are going to draw a solid horizontal line going through negative 2. Now, we want to represent values that are greater than negative 2, so we shade above our line because numbers that are greater are up. Number 4, negative y is less than 2. Here, this is another example where y is not positive, our variable. So let's go ahead and get y to be positive. Remember to do that, we're going to divide both sides by a negative 1. So divide by negative 1, divide by negative 1. Y, flip your sign, is greater than negative 2. So we have to graph the inequality y is greater than negative 2. Again, this is going to be a horizontal line, but it is going to be dotted or dashed this time. Horizontal, and it's going to be dotted. So at negative 2, I'm going to put a point on my y-axis. It is going to be a dotted or dashed horizontal line. And we want values that are greater than negative 2, which again is above our line. All right, number 5 and number 6. Take a second, press pause, do number 5 and number 6 on your own. When you are finished, have an adult in the room check your answers. All right, let's look at some more examples. These examples are a little bit more complicated. These equations have both x and y variables, which means we're going to rewrite these inequalities in slope-intercept form. Let's look at the first example. X plus y is less than negative 1. Remember that slope-intercept form, let's write this out, slope-intercept form is y equals mx plus b. Don't forget that m is our slope, so m is the slope. And remember that b is our y-intercept. And remember that a y-intercept is written as an ordered pair, 0, and then whatever that b value is. All right, let's look at number 7. In order to write something in slope-intercept, remember that we have to solve for y. So first, solve for y. So let's just write that again because these are our notes, and you always want to take thorough notes. So first, solve for y. All right, so if the inequality is x plus y is less than 1, we want to get y by itself. Now to do that, we need to subtract x from both sides of our inequality. When we do that, we are left with y is less than, now I want to write the minus x first, negative x or minus x, and then I'm going to put the minus 1 second, minus 1. So now our inequality is written in slope-intercept form. Now if I go over here, we can take a little bit more thorough look at this problem. Y is less than negative x minus 1. In this problem, our slope is negative 1. Remember, that is the value that is in front of our x variable. So here, remember that's our slope. And our y-intercept is 0, negative 1. Now that we have this information, we can go ahead and start to graph our boundary line. First thing we're going to do is plot our y-intercept, 0, negative 1, which is right here on our y-axis. Then we're going to use our slope. In this case, our slope is negative 1. Remember that that is negative 1 over 1, which means down 1, right 1. Down 1 over right 1. Remember, slope is rise over run. So from the y-intercept, we're going to go down 1 value and right 1 value and plot our point. And we're going to keep doing that. Down 1 value, right 1 value, down 1, right 1, down 1, right 1, down 1, right 1. And this is going to be a dashed line because we have a less than symbol. So less than. And the symbol is a less than symbol, which means we want to shade values below our line. So if we shade below our line, that is this region over here. Let's continue with the next example. Negative 2x minus y is less than negative 5. So again, the first thing we want to do is write our problem in slope-intercept form. So negative 2x minus y is less than negative 5. To do that, the first thing we do is solve for y. We're going to add 2x to both sides of our inequality. And when we do this, I'm going to rewrite this as negative y is less than, put the positive 2x first, and then the minus 5 second. Now we have one more step in this example, which is to make this y a positive. So we're going to divide everything on both sides of our inequality by negative 1. Now, we're dividing by a negative, so don't forget that we are going to need to flip our inequality sign. So flip the sign. So when we rewrite this, we have y is greater than negative 2x plus 5. So the inequality is y is greater than negative 2x plus 5. Our slope is negative 2 over 1, which means down 2, right 1, down 2, right 1, and our y-intercept is 5. So our y-intercept is 0, 5. So the first thing that we do when we're graphing an inequality is we always plot the y-intercept first. So 0, 5. That's right here. Next thing we're going to do is use our slope, which is down 2, right 1. So down 2, right 1. Down 2, right 1. And we can keep going down 2, right 1, as long as we want, or we can stop once we have at least 2 points. This is going to be a dashed line because of our inequality. So I'm just going to make myself a little note, dashed or dotted. So I'm going to go ahead and draw my dashed line. Now, because this is a greater than symbol, we want to shade values that are above our line, above or to the right, which is over here. So any value in that region is a solution to our inequality. All right, let's go ahead and look at the next example, number 9. So first thing we need to do is solve for y. So we're going to subtract 6x from both sides. And when we do that, we can rewrite the inequality. 3y is greater, write negative 6x first. And then since 12 is positive, we write plus 12. Then divide both sides by 3, and that means everything. And when we do that, y is greater than negative 2x plus 4. So this is the inequality that we're going to graph. Our slope is negative 2 over 1, which means down 2, right 1, down 2, right 1. And our y-intercept in this case is 0, 4. So first start by plotting the y-intercept 0, 4, which is right here. And then we use our slope down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then we are going to again draw a dashed line going through our points. And we want to draw values that are greater than, so that's above or to the right of our line. And that's all there is to graphing linear inequalities with 2 variables. Now if you turn to the front of your packet, you have an exit ticket. Complete both problems 1 and 2 and check them with an adult in the room. Once you have completed them with 100% accuracy, you can move on to your homework.